Hello everyone and welcome to the new episode of Data Structure and Algorithm course. So today we will learn about queue data structure and how to implement it using array. If you haven't watched a previous video about stacks, then do check it out. I have put the link to the complete playlist in the description box below. And before starting, if you haven't yet subscribed to my channel, then please do subscribe it and hit the bell icon for future updates. So let's get started. So today we are going to see how do we implement a queue, and at first we will see what is a queue. Okay, so a queue is a data structure and it is also referred to as a close cousin of stack. Okay, and a queue works with the principle first in first out, or you can also say last in last out. So what does it mean? So let me show you. So let's say this is a counter. Okay, so this is a counter. Okay, this is a counter in which we get a ticket to go inside this door. Okay, and here are some people standing in line to get to the counter. Okay, so this person is the first person to stand in line, right? And this is the last. This is the last. So let's say this is an actual movie counter where these person are standing in a line to get a movie ticket. So can a person from here just come here and get here and then wait for the line? No, right? You can't just simply move somewhere in between the line, right? So what he can do is he can only go here, right? He can only go here. One cannot just simply move somewhere in between the line, right? You have to go at the end. So that's the exact case of how we insert an element in a queue. We can't simply insert it somewhere here or somewhere at first. We can't do that, right? So we have to insert it here and so on. So we can insert here and so on. So now the last element is this, right? So and not this. Okay, now if we want this person to get a ticket, right? So before giving this person a ticket, we have to give him a ticket. Okay, if he gets a ticket, then only he moves inside here in the store, and then if he gets a ticket, then he will also go here, and then this person will get a chance to get the ticket, right? So we can delete a data from the beginning only. Okay, so a stack follows first in first out principle. First in first out, or you can say last in last out. So this person is at the first now, so he will get a ticket at first, right? So if he gets first, then he will go out first, and this person is at last, so he will get the ticket at last. So last in first out and first in first out. Okay, so I hope that you understood this. So let me show you other things now. So this is the exact same example that I have told you, and another example is in call center. Okay, so if a customer is waiting for a call and that customer gets a chance to talk with the customer care at first, who was waiting from a long time, right? Or who called first. So abstract, now we will see queue abstract data type. So a queue generally follows these two main abstract data types. So what is this? So queue.enqueue. Okay, so what it will do, it will simply add an element e to the back of the queue. Okay, and queue.deque what it will do, it will simply remove it will remove and return the first element from the queue, and if the queue is empty, then it will generate an error. Okay, and there are other abstract data types also, so and that is queue.first. So what it will do, it will just simply return the first element in the queue without removing it, and if the queue is empty, then it will return an error. Okay, and queue is empty, it will return true if the queue is empty, or if it doesn't have any element inside it, and len queue. So as you have guessed already, so len queue returns the length of the queue. So now let's see the implementation of a queue using array. Okay, so let me write here implementation of a queue using array. Okay, so at first we will create a class, say array queue, and then we'll define a function in it then we will say self.data is equal to an empty list, then self.size equals to size equals to 0. So what is it? We are initializing the size of the queue as 0, and we also want self.front equals to 0. So self.front is the index of the first element, and it will be always 0, right? Say the index of this element is 0, isn't it? And if we remove this element from here, so now this is our topmost element, sorry, the frontmost element, but still its index is 0, and it will be always true, isn't? If we remove this also, then now this will be our front element, and its index will be also 0. So that's it. Then we want to define a function, and what it will do, it will simply give us the length of the queue. So let's get the length of the queue. So we will simply say return self.size. That's it. That's all we need to do to get the length of the queue. Now we will say is define a function. We will define a function and say is empty. Okay, what it will do, it will return true if self.size equals to 0. If the self.size is 0, then it will return true that yes, this queue is empty. And if it's the size of the queue is not 0, then it will say no, the queue is not empty. Now we want another function that returns the first element of the list. Okay, so we will simply return self.data, then here is self.front. That's it. It will return the front element of the queue. And what if the queue is empty, right? So if self.is empty, if the queue is empty, right? If the queue is empty, then we want to print queue is empty. Then we want to return. Now we want to add something, right? We want to add something. So let's add something. Enqueue. So to add something, we will say enqueue. It will add data E or an element E inside in the back of the queue. So we'll say self.data.append, and we will give the value E, and then we will increase the size of the queue. That's it. Then we will need something to delete it. So now let's delete something from the queue. So we'll say deque. Okay, then here first we will say if the queue is empty, then we want to generate this message, right? That queue is empty, so we cannot delete something from the queue. Then after that we want to decrease the size, right? Self.size minus equals 1. Then also let's say answer equals to self.data.pop. Then here we want self.front. We want to delete the frontmost element of the data, of the list. Okay, then after deleting it, we will decrease the size of the queue, and then what we will do, we will return answer. Okay, so it will print the element that has been deleted. Okay, so that's it. That's all you need to do to delete something from the queue. Now we will call this. So we have say array queue, then queue.nq, and we will take some data, and let me copy it and paste it several times. Now I want to print the list. Okay, so to print the list we will say data. So here, so at first we added 23, then 3, then 2, then 213. So the order is correct. Okay, so now we will check whether 23 is our first element or not. To do that, we will simply say queue.first. Okay, queue.first, and also after doing that I want to deque something. So here also we will say print queue.deque. Okay, and the deque, then after doing the deque, I want to print the length. Okay, to print the length we'll say len. Okay, then after that we want to check whether now the frontmost element is something else or not. So let me just copy this whole thing and paste it over here. So at first this was our list. Then what we did, we turned the first element of the list, and this is the first element, right? 23 is the first element. Then we did deque. So after doing the deque, it returned the element that has been deleted. So 23 has been deleted, right? So after doing that, we printed the length of the queue. So after deleting 23, the length of the queue should be 3, and it's correct. Okay, so now we have printed the data. Okay, we have printed a list. So now 3 to 213 is the list, right? Then we printed the first element, that is 3, so it's correct. So everything is correct till now, and that was the implementation of a queue using array. So in our next tutorial, or in the next video, I will show you how to implement a queue using a deque. Okay, so that make it very easy to implement a queue. Okay, and so this was a lengthy process. Okay, so in this book it is shown that they have already uh, gave some value to the capacity. Okay, initialize a value of 10 to the capacity, and they also made the list of a size. Okay, the size has been kept as 10 also. Okay, so I didn't did these things because it doesn't matter. Okay, and then these are not okay. So now the runtime. Okay, so this is time complexity of queue. Okay, so in general q dot nq will take o of one time, okay, of constant time, although it's amortized. Okay, and the q dot dq will also take o of one time constant. It will take constant time, but it's amortized. And all of these things, q dot first, q dot empty, and length, will take o of one time. Okay, so the running time of all of the function is constant, so that's the good thing. So that's it for today's video. If you enjoyed this video, then do hit the like button and comment down your doubts, and feel free to ask me. So thank you and have a good day ahead. Hello.